G'day everyone and welcome back to the channel. As you can see, I've decided to go with the voltage doubler. I'm re-recording the intro of this video because somehow I deleted the wrong video. I was deleting footage off my phone to free up space and deleted the intro to this video. So that's why I've re-recorded this. So on with the rest of the video now. Alright, so I decided to just go for it. I've got the back of the unit open here. And I've soldered a wire to the AC side of the bridge rec. Don't worry, I know which side it is. And I've run, I don't need a breadboard this big, but the reason I put a breadboard this big here was in case I do decide to add fold back current limiting to it, we've got enough space to work with already because the breadboard's here. So I just figured that was a no-brainer. Alright, so I'm going to mock up a voltage doubler circuit with a Zener regulator, and then a wire is going to go over from that to the 2.2k resistor. I also need to run a wire over from ground over to here too. I think ground. I've got to build a voltage doubler anyway, and build a Zener regulator and then run that off of that. We'll see how much better performance we get out of that. The other thing I'm going to do, because I've got this sitting here, is I'm just going to hook up a couple of croc leads to this big capacitor. I'm going to put that in parallel with this capacitor. So when I put excessive loads on it, we don't get ripple to the point that the DC voltage drops because the capacitor is not doing its job anymore because it's so undersized, because that's going to screw with our measurements too. Excessive ripple and DC dropping because of undersized smoothing. So that will take care of that problem. We now have that. So I'll go mock up a voltage doubler circuit and I'll be back. Alright, so as you could probably tell from the intro of the video that I had to re-record, I've done some work. So I've just got 200 microfarad capacitors here for the moment on the voltage doubler, non-low ESR types. This is still running just as it was. It's not actually hooked up to this. This is in development. Now, I've actually decided what I'm thinking about doing. Well, okay, let me just show you this first. With it as it is, just with that 100 mic low ESR cap on the output. Not now, little man. Everyone's coming in. Hello. Yes. I'm a little bit busy now. Little man. No. You know you're not allowed to do that and you still do it. I don't care if it's only a little play. It's not fair, they're kittens. Right, anyway, I swear he understands me. You saw the look on his face. Guilty. Anyway, so I've got it set at 12 volts, 12.5 volts, and I'm going to put an 8 amp load on it. I know you can't read where it's set, but if I turn it on, you can see 7.98 amps. And if we look over here, the ripple doesn't change on the output of that, so that's good. Not that it really should, because it's going through a voltage doubler, not the rectifier that's getting loaded down off the main cap, and it's got its own filtering and it's not loaded, well, apart from the Zener. So can you not climb on there? I'm just gonna get the cats out. I'll be back. All right, that's that problem solved. So I've got a 27 volt Zener diode there, by the way. I wanted to use a 24 volt Zener. I didn't have one lying around. I didn't want to go down, that's right. I didn't want to go to 22 volts. So I went to 27 because I had 4750s, one in 4750s. It doesn't matter, that's perfectly fine. Under full load, the incoming voltage drops no lower than 30 volts to this circuit, 31, something like that. So there's plenty of headroom there for the 27 volt Zener and what I'm proposing to do. Now, I think this is actually a good thing to do because coming up, other than the power supply I'm building that's already half built, the constant current circuitry is not built, so you guys are going to see a lot of work on that. But for people who are learning, I thought we'll take this one step further and, well, we might. Let's see. What I'm going to do is I'm going to add one stage of filtering to this. Basically run that just straight off of that, see how much better the regulation is. If I'm happy with it, we'll just stick with that. If I'm not happy with it, we'll make a little 2 transistor Zener regulator. Basically, what I'm saying is one transistor will be a comparator, basically a small version of this, just with 2 transistors, a Zener, maybe compensation capacitor or 2, try and keep it pretty small and simple because it's all got to fit in this little box. But you'll be quite surprised, I'm very good with my circuit boards. I can fit a ridiculous amount into a small space. I'm just trying to think of an example that I've got lying around. Don't worry, I'll just prove it to you. So I'm not too worried about that. So yeah, that's where I'm up to now. I'm going to go do some measurements for ripple on this circuit, and I'll come back and I'll show you what we're doing, what we've got and what we're doing. Okay, some things I've got to point out because I've made some mistakes and I've got to point it out. When I thought I had about 10 milliamps without the Zener and the transistor in that current path for the collector, I wasn't taking into consideration the two 1K resistors for the 2-stage RC filter. With them in consideration, giving it a total with the 2.2K, a total of 4.2K, that's only 5.7 milliamps. Anyway, that is actually how we got the best regulation out of it, so I'm not going to question it. Now, what I'm up to now, I've been thinking about this 2 transistor Zener regulator or just the capacitive voltage doubler and a Zener shunt regulator. I'm about to test that now. What I've just done is I've worked out what size of capacitor I can get the doubler capacitors down to, which seems to be 33 microfarads. I think 22 would do the job, but I always like to go a little bit extra because the thing is, capacitors can age and stuff over the years, and you don't want everything on the edge of its capacitance, its current, its voltage. I like to leave headroom in my designs. So, not that much headroom. They don't belong in there or them. But 33 mic, yeah, I'm happy with that. The Zener is lukewarm. There's a 1K resistor, is it? Yeah, 1K dropper resistor. 27.23 volts. I'm just going to load. Actually, I don't know what my output's set to. You know what? I don't have drive. Okay, I'm going to have to stop recording again and just set a couple of things up. I need to take a few more measurements, but I just wanted to point that out in case anyone's learning here and they were trying to learn how to do the math on this. When I was calculating the current across this dropper resistor, the two that are in series for the RC filter are also part of that resistance. I should have noticed that myself, and I just wanted to mention that for the video. Anyway, I'll be back in a moment. Alright, so what I've got is, sorry, my scope probe cable's kind of in the way. There we go. Voltage doubler, two 1in4 007 diodes, 233 mic at 25 volt. Caps, 1k resistor, 27 volt Zener, two 1k resistors, three 100 microfarad, just normal, 63 volt caps. They've got a fairly low ESR. 3.3k resistor. That's what I changed the 2.2 to. I just want to show you this, because now we've got 3 points of reference, and I'm not going to do the 2 transistor. We don't need it. I'm very happy with this. This is unloaded. I'll just show you on the scope. Remember, forget about the 12 millivolts peak to peak. I proved this in the last video with the filtering on the output. There's a reason that's there. We're concentrating on the RMS, which is literally 560 something microvolts. And if I load it at 2 amps, 700, and that's at 18 volts. What the hell? What the? Dude. Oh, was I pressing the escape button? Look, 2 amps, 3 amps, 17.6 volts. That's at this end of the cable. Over here, we're at 17.91. So I'll unlock that, put that back down, relock that. So we're getting, like I said, by adding more drive current to the voltage, sorry, to the comparator, we can get more power out of it. So that's doing, look, that's a 2 amp load, that's a 2 amp load off, 10 millivolt difference. I mean, this isn't even a precision power supply, and we've got 10 millivolts of accuracy, and that's at the worst end. Let's see, I'm gonna have to get a better meter. So yeah, I'm happy with this. I'm happy. This is more than enough. I told you guys I'm fussy when I build stuff. Yeah, I do mess around a little bit too much, but the end result, it's worth it. Oh, don't tell me I've done it again. Oh no. Cool. Alright, so 2 amp. That's great. Wow. Let's go down to 12. I'm going to turn my load up to 8 amps. Why not? Oh, oops, pressed the wrong button. 8 amps, here we go. Oh, you gotta be shitting me. Oh, I'm really happy with this. This is a beast. Now don't forget, we don't know how long we can pull much power out of this. I know the transformer can handle the 8 amps, and I know it was a 13.8 volt power supply, so, and the transformer was an 18 volt transformer, so you'd be able to get, I'd say the transformer would handle about 7-8 amps up to about 18 volts continuously all day. The heatsink, on the other hand, with the transistors, that's where we're going to run into difficulty. But that's okay, because I'm not intending on using this for high current, and obviously I'm going to, do my tests and measurements and that, and find out what it's capable of. And we'll work it out. That's all part of the design. I might, when I put foldback current limiting into it, design a limit into it so that it can't exceed that. I don't know yet. It'll be hard to do that and still go up to 18 volts unless I limited the whole thing at 2 amps, which would kind of be a waste. So I'll probably just put a label on the front of it that just notes what current, what max currents you can use at what voltage. So, you know, I don't ever pull more out of it and cook something. I'm really not too fast. My aim was to get good regulation. My apologies, my phone just died. What I was trying to say was my goal was to get good regulation, low noise, and adjustability out of it, which is what I've got. Just turn that load off. I've just noticed incidentally that the two capacitors that I meant to put 33 mics in are actually 22 mics. So I'm just changing them for 33 mics, which is what I calculated. And it's working great as it is already, so 33 mic will definitely do the job. And they're smaller because these ones are 25 volt caps, not 63, which is going to help us with our space saving. I've only got 27 on the output. Let me see if I've got hundreds at 35. I'll be back in a sec. Alright, I couldn't find anything else suitable, but what I did notice I had lying around was some 220, just stabbed myself with capacitor pins, legs. 220 microfarad at 35 volt, which I wouldn't mind using as the last output capacitor here instead of 100 mic. So 100 on the Xena, 100 for the first RC stage, 220 for the second. Yeah, that's nice and clean. 500 microvolts. Yeah. So what I'm going to do now, because I am more than happy with the performance of this circuit, all we now have to do is make up the board, assemble it, and then work out those capacitor values for the compensation components and snubber networks and the common mode filtering network on the front. But other than that, this is it. I did take my time this time and prepare properly, so don't worry, everything's here. I'm going to go off now and draw a schematic in a relaxed manner and not rush it, and I'll come back and we'll take a look at the schematic and get to making the circuit board up. If the video's gone on for too long, I may just upload this too and leave the etching and populating to the next video. I'm not too sure. I'll see. I don't want to make the videos too long for people, but I did say that I was going to try and make 5 or 6 videos, so I'll just have to see how it goes. But I think this is a good learning curve for people that aren't already well versed with electronics, because coming up I'm going to be building microamp supplies, constant current circuitry for my big precision supply, upgrading a couple of supplies I've already got. And when I talk about regulation and stuff like that, it's good for people to be able to understand. So whether you're using an op-amp, transistors, a single comparator, transistor as a single comparator, a single transistor as a comparator, you'll notice that we still have a reference voltage feeding the transistor. We have a reference that the transistor's comparing against, and we also have a reference in the feedback path. It's actually there to set the high limit, but when you turn the voltage up and that Xena comes on, it actually acts as a reference in the feedback path. So, and you've seen as I've designed this circuit, the regulation get better and better and better and better. So I feel like that's a good learning curve for people. Yes, I made a few little boo-boos and said silly things along the way and corrected them, but still, I think everyone gets the main point, and you can see the circuit improve as I play with it. You got to remember, I don't copy circuits, so I do all this myself, you know. Yes, obviously I could have just hidden stuff off of my computer, but no, seriously, I shit you not, all I have is the data sheets and a calculator. That's it. And a Zener diode data sheet, purely so that, because I can't remember all these numbers for the different Zener voltages. But yeah, so you got to understand, the bit I messed up in was preparation. I'm not doing preparation, but there will be small mess ups anyway, even with preparation, when you're designing something on the go, because it's just the nature of it. Anyway, I think that's all I've got to say for now. So I'll be back soon. Alright, after some careful considering, I've decided not to draw the schematic up yet. Well, I'm going to edit the schematic and add this voltage doubler Zener regulator bit to it, and I'll show you that. But before I do the circuit board, I've decided I am just going to add the foldback current limiting. I'm looking at the components here. I know I can fit all this in there. It'll be fine. That capacitor and that resistor doesn't go on the board anyway. That's going to go across the output terminals. So if you ignore that, it's some very small, and that capacitor's not there either. So it's some very small components. The board space I have is a little bit bigger than this, minus that circle in the middle. I will be able to fit another, what? I need a resistor, a transistor, and it's not going to take much to add foldback current limiting to this circuit. So I'm going to do that now, and we'll have a look at that, and then I'll draw a schematic for that. But I'm still going to draw a schematic for this too. Incidentally, I've got some other stuff that I went and got today too. Showed you in the first episode the butchered plug that was on this thing, so I went and got a plug from Jaccar. I also picked up from Bunnings some drill bits and some step bits, because I've got a Dremel here with some cut-off wheels, and I've got those nibbling tools. So with this and those, I'll be able to get the front panel done. It's not ideal. I need still to get a couple of power tools that I'm missing. Not really a couple, but yeah, a couple. I need some sort of reciprocating tool, not like a reciprocating saw, but something that's good for cutting through hard steel and, you know, cutting small sections, you know, like a little window in a piece of hard steel, for example. I need a tool for that, and I also need a jigsaw. Wouldn't mind getting a table saw too. But other than that, I have everything else. I need grinders, drills, drop saws, you name it, everything. So I can get the front panel made up now too, which is wonderful. I feel like I'm missing something. Let me just pause the video for a second, take a look around, because I'm sure I brought something else home today for this too. Never mind, I had to get circuit board cleaner and 100 microfarad 63 volt caps, these guys. That's all it was. Nothing else related to this. So, yeah. Alright, I'll be back with a schematic in a minute, and I'll show you the updated voltage doubler Zener regulator part. Alright, so I've redone the schematic. I'm just going to hold it here. Actually, it's probably better the closer I hold it, because my writing's not the best. That way people can actually read it. I guess you can pause, so I'm not going to hold it forever. So that's the modification there. And here we're now 100% certain that that's going to be 3.3k and that's going to be 1k, so there's no question marks there. The only components we have left now are the ones that we've got to calculate after we've populated the board. We still, however, have one more thing to do, and that's to add foldback current limiting. So I'm going to have a look how long this video has gone for. And if it's gone on for too long, I'll upload it, because at least that's the end of the voltage half of the thing done. And then if it hasn't gone on for too long, well, I'll keep doing it now. Otherwise, I'll make another video. So I'll just go have a look. Well, I've just been thinking about designing a fold-back current limiter for this, but it's tricky because at 18 volts, you want to limit it at 1 or 2 amps, or... Actually, I can't even remember. Hold on, let me just load it. Sorry. Yeah, 2 amps. It's fine at 2 amps at 18 volts. Now, the problem with that is the resistor would have to dissipate so much power for me to even set a 2 amp limit on it. When it's turned down at, say, 12 volts, even a, let me just work this out. Look, a 0.1 ohm resistor with 8 amps on it, 6.4 watts. So that's already meaning that I'm going to need a 10 watt resistor, not a little 5 watt like that. That guy there. Right? So then it starts getting into the realm of building a current shunt. But look, that's not a problem. I've got a whole roll of 18 standard wire gauge Constantine right here. I can make a nice shunt that can dissipate a lot of power and have a decent temp code still. Thing is, where would that fit also, just like the resistor? Because you can't solder to it, so you got to terminate it somehow, screw blocks, some method of terminating it, plus the size of it. You want to try not to coil it up to keep the inductance down, because it's going to get long, so it's going to end up like a zigzag going back on itself. It's doable, but I mean, like, I'd be really pushing the limits of the space constraints in here. Already this is just going to fit on the board, so I think I'm going to leave it just as a voltage power supply, only constant voltage. I could put, I could completely redo the whole circuit and make it all op amp based and way more accurate, but that was never the goal of this project. The goal of the project was to make a simple, quick power supply out of an old Motorola unit that's just sitting there doing nothing. So I've got an extra rail when I need it. And I'm quite happy, It's got decent regulation. It can put out decent current. That's fine. Goes up to 18 volts. Good enough. So I'm not going to worry about current limiting. Maybe after I make the board up and put it in there, if I actually look inside and I'm like, hey, there's actually still quite a bit of space in here and I think we can do it, we might come back to it in the future. Like, the board's going to sit here and the capacitor sits there, and there's going to be a panel meter there or there. So there's not going to be much space, but there might be some space sort of here where my hand is in the top of the case. Like, I might be able to put some standoffs off of the cover, the lid, and mount a board backwards to the roof and put the constant current circuit on that. So we might come back to it in the future and do that, but probably not, to be honest. But yeah, for now we're just going to do this. So I'll just grab the schematic again one more time, and I'll put it on the table so everyone can get a good look at it, because that is the final schematic. Oh, actually, no, you've already had a look at it, nothing's changed. I won't do that because we got to etch the circuit board up and we've got to change capacitor values for snubbers and compensation networks. So we'll do all that, and then I will write those values on the schematic and then show the schematic again. So I think I'll just upload this video because that concludes the whole design phase of this. I'm happy with the design, and the next video will be etching and populating the circuit board, putting it together, and then the video after that will do the compensation. So I guess I'll make 3 more videos for you, but at least they won't be too long, because the first couple were getting too long, so I'm trying to make them a bit smaller. Anyway, thanks for watching. If you like my content, please like and subscribe, and feel free to comment down below, and also feel free to ask questions. Alright, I'll see you in the next one.